my name is Dr. Ayan Debnath. Welcome to my second video of activation function. In first video I have discussed about the introduction of activation function. In this second video I am going to explain about the type of activation function. So here we can see there are total 11 types of activation function, and apart from that there are some other activation functions, but these are the very important and widely used activation function. So I am going to explain each and every activation function in details. Before going to start different types of activation function, first let me explain you two very important things. One is forward propagation and another is backward propagation. So when we are giving the inputs, then it goes in this direction. Like inputs are given, then it's being multiplied with the output, weight is bias is being added, then activation function is is implemented on the top of it, and then we get the output. So when we do this thing, so this is called forward propagation. And when we are going from output to this direction, it happens because we want to adjust the weight so that we can train our model. So first we will go in forward propagation, and then we will come towards this input direction because we want to adjust the weight and we want to do the training. So this is called backward propagation. The concept of backward propagation will be highly used in these different types of activation function. First of all, I will explain linear activation function. This is also called identity function. Here is the mathematical graph. So for all values of x, we will get similar values of y. It means when x is 1, we are getting value y as 1. When x is 2, we are also getting value as 2. When x is minus 1, then we are also getting y as minus 1. So the formula we can write it like this: f of x is equals to x for all values of x. This symbol is for all values of x. That is why it is called identity function, because input is equivalent to output. Now coming to the derivative. While we are doing this back propagation, then we need to do the derivative, and at that time we can see that derivative of this function will be constant. Why this will be constant? Because this will be a certain value, that is, it will be a kind of constant, because derivative of f of x, it will be derivative of x with respect to x. So as a result the value will be constant. So one of the disadvantage of using identity function is that since the derivative, like the gradient is constant, so it can't be used in back propagation. This is our disadvantage. This is disadvantage. Now coming to advantage of it, this is a pretty simple activation function to use, and advantage will be it is like it doesn't consume much time, because it is very simple thing. Like time consumption will be very less. So for this purpose we can use activation function in certain cases, like in case of regression, say for example like for house price prediction, or in case of like stock, where we can use regression problem. So at that time we can use linear activation function. One more advantage of this thing is that how many number of layers are there within the hidden layer of the neural network, still the output of the neural network will be similar to that of the input layer, because the output is a linear function of the input, and as a result whatever we are giving in the output is similar to that of the input layer. That is why I mentioned that input is equivalent to the output. Second one is step function. This is the graph. Now let's write the mathematical formula. We can write it as f of x is equal to 1 for x greater than or equals to 0, and this is 0 for x less than 0, because this is 1. So when x is less than 0, then it is 0, and when x is greater than 1, when x is greater than 0, then the value of y is 1. We can also write this in terms of threshold. So in spite of 1, we can also write this is equals to t when x is, this is equals to 1 when x is greater than equals to t, or it is 0 when x is less than t. So where t is the threshold, like in spite of, here it can be 0, or maybe you can treat it like it is t. 0 can be anywhere. Derivative of a constant is always 0. So derivative of a constant, the value is 1. So derivative of these things will be 0, and also when x is in the negative direction, so derivative of another constant is always 0. So hence, since the derivative is always 0, so this can be a hindrance to the back propagation. So this becomes an disadvantage. Since derivative is 0, so it is a hindrance to back propagation. Here we can see that either the value will be 1 or the value will be 0. So it means that, now coming to the advantage. So neuron will be either activated or deactivated. It means that, or deactivated, it means that when the value is 1, so at that time neuron will be activated, and when the value is 0, at that time that neuron will not be activated. So we can use this thing in case of, say, for binary classification. When we are classifying, say we are giving an image of a dog, and we want to classify it whether it is a dog or not. So if the output is 1, so it means that it is a dog, and if the output is 0, it means that it is not a dog. And also, so it can be used in case of binary classification, and this is computationally less expensive. Third activation function is sigmoid or logistic activation function. As it says, the curve is of S shaped. We can give any real value as an input, and in the output the value will range between 0 to 1. So it shows that, like, for any value of x, the value will be either 0 or 1, or it will lie in between 0 and 1. If we go to more positive x, the value of output will be more near to 1, and if the value of x is more towards negative, the value of output will be more towards 0. This is mainly used for binary classification, because if there is any value, if the output is, say, 60% of something, then above this it will take value as 1, and below this, like if say 40%, then the value will be 0. It can be also used in case of classification problem where we are classifying whether it is a dog or cat. If the output is 1, so we can say that it is a dog, and if the output is 0, then we will say it is a cat. Now coming to the derivative of this, because in back propagation we need the derivative of this function. So let us first understand how the derivative of this function will look like. This is 0.25. Now what happens is that when we are doing this back propagation, we need to update our weight. So weight new will be equals to weight old minus eta, which is actually learning rate of this of old, where this is learning rate and this L is actually loss, and W is the old weight and this is the W new is the new weight. So what happens is that since the derivative of this sigmoid function is very less, like the value ranges between 0 to 0.25. So what happens if the value of x goes beyond 3 or goes like beyond -3, then the derivative of this function will be almost nearly 0. And if the values lies between -3 and +3, then still the value of this derivative will be less than 0.25, which is very low number. So we can write it as this W of old minus eta into derivative of loss. How we are calculating the derivative of loss is that the derivative of loss with respect to an output multiplied by the previous output. So like this way we write the loss function, and this is this is based on chain rule. Okay, so when we are taking the derivative of this function, there might be some value which comes as like this or some other small number. So what will happen? W of old minus eta into a small number, and as a result of this small number, this will be almost equivalent to 0. So what will happen? W of new is equals to W of old. For this reason, there will be no updation of weight. Since there will be no updation of the weight, so this will lead to vanishing gradient problem. So this is a big disadvantage. Vanishing gradient problem. Logistic function or sigmoid function is widely used. Like in most of the classification problem, this is generally used. And since this is a kind of S shape, or it's a very kind of like smooth function, so there will be no jump in the output values. Smooth function.